Hello, thanks for coming along to this YouTube session on sequences and the nth term. What will follow shortly is a Zoom lesson that I delivered to a class earlier on today. The recording's not without its faults. It's the first time I've tried to video a Zoom lesson, and I did try and use my screen recorder. So there is a little caption in the top left that doesn't go away, and I am a little bit hesitant, but hopefully you will find this video useful, and thanks again for coming along. Cheers. Right, so if you have just logged into my YouTube video, you have just joined a Zoom lessons with my wonderful class on sequences. Okay, I gave the class a few seconds to try and match up an orange card with a pink card with a green card. I'll just read through what they say on them because I know that particularly on the orange it's not particularly clear. N going in, add 2, N times 2, N take away 1, times 3, times 2, and then take away 1. You're matching those up with these cards, n minus 1, 2n, 3n, 2n minus 1, and n plus 2. And on the green cards, you've got sequences. The position in the sequence is at the top. That will always be 1, 2, 3, 4, 5. I could continue it more if I wanted to. These terms are the numbers in the sequence. So the first sequence goes 3, 6, 9, 12, and I've left a space for you to predict term 5. Okay, so in today's session, we are going to look at the nth term. And this leads into that. If you want to pause your video now and have a go at matching them, then you're more than welcome to. Okay, so if we have a look, the first one, n plus 2. So adding 2 to a number, the general number n, which will eventually be the term number, will be there. Well done those of you that predicted that correctly. So whatever n is, we are adding 2 to it. So the numbers 1 add 2 is 3, 2 add 2 is 4. So it must go with green 3. Well done to my students if they got that one correct. When we times n by 2, I could write n times 2, but you won't see that anywhere there. When it's something times n, something n, 2n. So, whatever the position is, we are timesing by 2. So we're looking for the 2 times table. Well done if you got that correctly as green 5. Okay, let's move these out of the way slightly. Taking away 1 from n, we write as n minus 1. So if n went into that function machine, the thing that would come out would be n minus 1. So whatever the position is, the term is going to be 1 less. I don't know if you've noticed already, but when it's just n, the sequence goes up in ones. N times 3, hopefully you got as 3n. So if we times n by 3, we get 3n. It's almost like the times is hidden when you've got a number times by a letter. So we're looking for the 3 times table. There we go. 3, 6, 9, 12. In the last one, timesing by 2 and then taking away 1, 2n minus 1. So we're looking for numbers that are 1 less than the 2 times table. 2 times 1 is 2, take away 1 is 1. 2 times 2 is 4, take away 1 is 3, and so on. Now, if we look at the last missing numbers in these sequences, you can see this is going up in 1, so I suspect that you've already written 7 there because you've continued the sequence just like we did last time. You could use this expression here. The nth term is n plus 2, so here 5 plus 2 is 7. In the next example, 2, 4, 6, 8, you probably know it's going to be 10 because you can predict, but we can check that. 2 times 5 is 10. 5 take away 1 for the next one is 4. 3 times 5 is 15 for the second to last one. And on the last one, 2 times 5 is 10, take away 1 is 9, and that continues that sequence nicely. Okay, so well done if you got those matched up where they are, and I'm going to look a little bit more. I'll leave those there for a second just so you can check. Obviously you'll be able to pause this if you're watching on YouTube. And then I'm going to take us on to looking in more depth at the nth term. Okay, so let's move these out of the way. So when we are talking about the nth term rule, we are talking about the position to term rule. Okay, so when we talk about the nth term of a linear or arithmetic sequence, one that goes up by the same amount each time, we are talking about a position to term rule. So I'm just going to try and zoom in on that a little bit more because my writing looks a little bit small, doesn't it? Okay, that's a little bit better. Okay, so here's a sequence that you may have seen before. 5, 10, 15, 20, and so on. Now, last lesson, you would have been asked to predict the next terms and say why. So you'd have probably said it goes 25, 30, and so on, 35, because the term-to-term rule is add 5 each time. Now, a lot of people then say, oh, the nth term rule is going to be n plus 5. The position-to-term rule is not plus 5, that is the term-to-term rule. It's going up in fives, so the times table that it is linked to is the 5 times table, or 5 times the position. So the first number, 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, 5 times 4 is 20, and so on. So there's your term, and there's your position. Okay, what you might also be asked to do is something like predict the 10th term. Now, you may have been able to do that last time by just keeping on adding 5 until you got to your 10th number. However, it's much quicker if we do 5n becomes, when n is 10, 5n becomes 5 times 10, which is 50. So the position to term rule is really, really useful for predicting terms in a sequence. Okay, sorry, I'm just checking for participants in my Zoom meeting. If you're not sure what I'm doing, if you're watching on YouTube. So let's do another example, and I'm going to make this one a little bit harder. So the terms in my sequence are 6, 10, 14, 18, and so on. So just have a little think to yourselves about what the nth term might be while I just write in the positions along the top. So we've got a sequence where the first term is 6 and the term-to-term rule is add 4 each time. Okay, so it's going up in 4s, so the times table that it's linked to is the 4 times table. So it's linked to 4n. Now I know the 4 times table does not start on a 6, it starts on 4. 4 times 1 is 4. The second number in the 4 times table is 8. 4 times 2 is 8, not 10. 4 times 3 is 12, not 14. But all of these numbers are 2 more than the 4 times table, sorry. So it's 4n plus 2. Now here, I'm going to try and catch you out. I'm going to write out another sequence. I'm going to give you a couple of seconds to think about it. So 6, 9, 12, 15. So those are the first 4 terms. Okay, so the reason why this is going to be quite confusing is, well, it's going up in threes. The term-to-term rule is add 3. So it's going to be linked to the 3 times table, but you need to be really, really careful with examples like this. All of those numbers look like they're in the 3 times table, but the rule is not 3n. If you think about it, the 3 times table does not start on 6, it starts on 3. So the second number in the 3 times table is not 9, it's 6. We need to add 3 to those numbers. Okay, now again, I didn't do this last time, but I could ask you to predict the 10th number or the 10th term. So if n is 10, the nth term is going to be 3 times 10 plus 3, which is 30 plus 3, or 33. So those are examples of ascending sequences where the term-to-term rule is add something each time. Here is a descending sequence. This one is going to go 15, 11, 7, 3, and so on. So those are the terms in the sequence. So the first term is 15, second term is 11, third term is 7, fourth term is 3. So it's going down by 4 each time. So because it's descending, it's going down. Instead of being linked to the 4 times table, it's linked to the minus 4 times table. So minus 4n. Now if it was just minus 4n, the first number in the 4 times table, minus 4 times table, would be minus 4 times 1, which is equal to minus 4. To turn this minus 4 into 15, I need to add 19. So the nth term is minus 4n plus 19, or you might see that written as 19 minus 4n. If we then try to predict the 10th term, we would do minus 4 times 10 plus 19. So minus 40 plus 19, which gives us minus 21. Okay, so that's going to be the end of my YouTube broadcast. Thank you very much if you came along. Take care.